Thank you. Foremost expert, I'm already like, I wouldn't put myself anywhere close to that category, let's be fair. But open source security is something that gets a lot of attention. It's been getting attention as long as I can remember. I've been in this field 25 years. And I mean, I can think back to those early days when I was a developer and we were talking about it then. Like, what do we do with this stuff? And, you had the zealots who were like, open source is the most secure thing out there because everybody's looking at it. Everybody's making sure it's secure. And on the other side, you've got, well, yeah, but we don't know who these developers are. We don't know what's going on with these maintainers. They might be doing work. They might just leave vulnerabilities in there forever. We don't know what they're doing. And it's all valid, but at the end of the day, it gets tiresome. And that's why, this whole concept of open source fatigue is kind of a thing. So before I dive in, let me tell you a little bit about myself. That's me, if you can't tell. That's my airplane behind me. Why am I talking about airplanes? So I just bought this. It's a Cherokee 180, not important. But what is important is how much I'm learning about aviation. So I'm a student pilot. I've wanted to do this my entire life, and I'm now divorced. I am an empty nester. My last kid went off to college. It's wonderful, by the way, yes. Every bit as good as they tell you it is. See, you're with me. So I have money and time. I got a really good job. I could actually afford to go out and buy an airplane. So I've been learning a lot about, what goes into being a pilot and owning an airplane. And if you've never seen it, the FAA regulations for aviation are incredible. Okay, so there's a company that takes like a subset of them, and the regulations book that I have to study and know is this thick. That's not an exaggeration. Called the FAR AIM. If you go look it up, it's wild. But one of the things they do, because we all understand the need for safety in aviation, right? And we've all heard the stories. We've heard about plane crashes. We understand all those different things that have gone on. And so the FAA and the NTSB are always working together with their international partners trying to figure out how do we get safer. Now, this plane is from 1968. But even back in 1968, one of the things the FAA understood was the need for this information. This is the mandatory equipment list for my aircraft. This is everything that is installed in that aircraft beyond just the airframe. So you'll see electronics in there. I mean, if I had an autopilot, that would be listed. Now, why do they do this? They do this so that when there's a problem, you have something to track back to. They do this so that when you make a substantial change to your aircraft, it can be seen and documented, and you can start to figure out, okay, I'm going to replace this piece of avionics equipment with something else, and it's going to have this impact on my aircraft. So that's my little plane. Well, here we have the 737 MAX 8. Anybody remember that? Oh, yeah. This is where we now connect why I'm talking about aircraft to software development. Because you see that same standard equipment list, that exists for this plane too. That mandatory equipment list, or required equipment list, excuse me. The 737 MAX 8 is a perfect example of how things went wrong because Boeing, and I apologize to my friends from Boeing, you're not the only ones, Airbus is just in the same boat. And this is not judgmental, but this is the reality, okay? A decision was made to save costs on recertification, and so rather than have to go through the massive amounts of what we would call regression testing to get the FAA to certify a new aircraft, and then force everybody to be retrained on how to use that aircraft, they decided instead they would create a software fix. Is this starting to sound familiar? Does it sound like some of your jobs? And, you know, the end result, the problem wasn't actually the software at all, right? The software did exactly what it's supposed to do. It was the fact that you had hardware that was failing and wasn't redundant. And so when that piece failed, well, the software kind of didn't know what the hell to do. So it basically pitched the plane up really high and down it came. Those are bad things. But this happens when we talk about open source. We have these bad things that pop up and suddenly we have to react really, really fast. And we wish we had that list. We wish we had something we could go to. We wish we could figure out a better way. But it keeps coming up. And every time it comes up, it's like it was with the 737 MAX 8, where we shut everything down. Every 737 MAX 8 on the planet was grounded. This happens to us when open source has a vulnerability. Now, I can go back, you know, Todd said a couple of years. This was, God, almost 6 years ago now. Equifax. There's a vulnerability in struts. Okay, well, that's really bad because lots of people at the time used struts. So everybody knew they had to go fix this. They ran out and they tried to fix it. But you know what? And we can argue about how it happened all day long. I'm not getting into that. Please, that's a whole other argument. Some people lost jobs over this. But somehow or another, there was that version of struts existed somewhere in the Equifax environment that they didn't know about. They weren't able to find it. Despite all their best efforts, they were breached. And we all know how that went. 164 million consumers worth of data. At the time, it was the biggest one. Now, then, you know, other things happened. Yahoo, who we all forgot existed, somehow exposed 3 billion people. So, I mean, it continues to get worse. But then, you guys remember this from last year, right? Ooh, getting down to Christmas and New Year's, and hey, fresh, we got a vulnerability called Log4Shell. We even came up with a cool MS Paint logo for it because that's what we in security do. I don't know. Don't ask me. To my fellow security people, I don't know what the heck we're doing. We are bizarre. But, you know, hey, there's a vulnerability. Oh, wait, nope, there's another one. Oh, wait, no, there's another one. So what did companies do? We ran out, we shut down all of our developers and got them all lined up. Hey, go find everywhere you got Log4j and we're going to fix it. We got to fix it right now because it's critical. Everybody's telling us how bad it is. Wow. Think of all the development that didn't happen in those weeks and months following the announcement of this. And how many developers are sitting there at their desks, digging through old code, trying to figure out, does Log4Shell even exist? Is it a reachable vuln? Do we even use Log4j at all? Who knows? I had people asking me, by the way, you know, is my C# app vulnerable? Let's talk about what Log4j is, okay? But that's the thing that happens. We get into this mode, we start panicking, we keep going, and then, you know what? We find out 91% of Java apps have this thing. Holy crap. 61% of those, and this is the kicker, 61% of those were in indirect dependencies. So it wasn't something where I could just go look at my manifest and say, oh yes, I have Log4j in there, I should probably look and see if it's vulnerable. Nope, it's not the vulnerable version, I'm good. By the way, this is so cool because this is one of those examples where not updating your code made you safer. If you don't have version 209 or better, hey, you're actually okay. Good job. Way to stay on that older stuff. But this, you know, so again, just think of how much of a pain in the butt that is. If you're not a Java developer, you didn't have to suffer through this, consider yourselves lucky. And then a little while later, we had Spring4Shell comes up. Oh, there's another couple vulnerabilities in Spring now. And of course, we got all really excited, and then we found out, yeah, that's like not even a tenth as bad as what was going on with Log4j. So we got everybody all spun up because Log4j was fresh in our minds. We knew we had to get it fixed right away. It's a critical vulnerability. They're telling us, oh, wait, let's start looking at those CVSS numbers. Yeah, they're really, okay. Maybe this isn't such a big deal. Oh, wow, that list of exploitation sure is a long process. But the coup de grace. Who timed this? I must know. Is there anybody here from the OpenSSL project today? Probably not, because y'all are about to dump another one on us. And that's not me picking on OpenSSL, just to be clear, all right? But I don't know how this happened, that the perfect timing, today, possibly right now, sometime before noon, we are gonna find out about another big, horrible vulnerability. This time it exists in one of our favorite packages, OpenSSL. And oh, by the way, OpenSSL isn't just Java. It isn't just any one particular ecosystem, so this could get really interesting. We don't know. So why does this keep happening? And why do we keep driving developers crazy? Well, to my security folks in the room, we suck at this idea we call DevSecOps. Andrew Schaefer, Patrick Dubois got together and they, years and years ago, and they came up with this whole concept that we today call DevOps. And security, we're kind of like, ooh, us too, we want to be in the room. But when we come to the table, what do we bring? We bring a bunch of tools that break the pipeline, that create quality gates, which if you're in CI/CD, the concept of a quality gate is trash. All right, I'm just going to be blunt. You can't have quality gates in a CI/CD pipeline. It doesn't work that way. But that's our approach. That's how we've always done it in security. Our tools are separate. They're written by security people, half of whom don't even understand developers. We need tooling. If we're going to bring tooling and automation, it's got to be a part of the pipeline, and it's got to be credible. We also, in security, have this problem of perfection. The quest for perfection. Oh, we got to fix that vulnerability. We got to get it out of every system on our entire ecosystem, all across the entire environment. You really? Who's exploiting it internally? Yeah, maybe we want to get it fixed there eventually because someone, if they were to breach us, could pivot, and that speaks to resiliency. But how do we just get a little bit better? Well, if I accelerate my CI/CD pipeline, if I have a strong CI/CD pipeline and I'm doing my releases multiple times a week, multiple times a day, multiple times an hour, imagine how fast I can fix vulnerabilities when they need to be fixed. So if we don't stand in the way of the pipeline and instead help accelerate it, that's better for security. That's a concept that many of my peers and my colleagues in the security space, we just don't get. It's scary. Wait, you mean they're intentionally going to release with a known vulnerability in their code? Yes, because they can come back and they can fix it 2 releases later because they put it on the backlog as a P1. And that's the focus. We need to be focused on resiliency and how do we limit the attack damage, if you will. Not trying to eradicate every vulnerability from our environment. We need to be realistic. And so when it comes to these scary incidents where the walls are falling down all around us, we need to be smarter about how we address that, because I'm telling you, this crazy spin up a bunch of scary stories every time we've got vulnerabilities, yes, they're bad, but all we're doing is beating our poor engineering teams to a pulp. Stop, slow down, take a process and understand what is going on. How many of you, when these came up, heard about it's all hands on deck? Got to have everybody there. We're going to have this big scary. My CIO just said it yesterday about this OpenSSL thing, and I wanted to scream at him. No, it's not. We are not stopping development. We are not slowing down. We're going to keep people working. What are we going to do? We're going to start off by prioritizing. When these details of OpenSSL come out today, we're going to figure out what's the most immediate attack surface. It's probably going to be internet facing. It's pretty obvious. We're going to classify that prioritization. What is the highest risk part of our environment that we need to focus on first? And we're going to look at what's most likely to be exploited out of those. And then we're also going to look at, well, do we have certain environments that can be remediated easily? Let's nail those quick, right? If I can get ahead of those spaces first, I'm already making myself more secure and I'm protecting myself. Now, then we need to mitigate. Now, mitigate is not fixing. Mitigating is, you know what? There's a bunch of security vendors today who have advanced notice what this vulnerability is. People like Cloudflare and so forth, who I can work with them. They can give me some mitigations. We can start to protect that front surface fast. I can fire up my web application firewalls maybe. We'll see what the vulnerability is. I can isolate where it's possible, make sure I'm logging, and just work my way through those risk prioritized categorizations. And then finally, I can start working on remediation, which is, all right, let's look at what the threat vectors are to these apps. Is that vulnerability even reachable? Does it have to be fixed here? And let's start fixing it. But let's put it in the backlog. Let's make it business as usual for how we address this. Sure, it's P1, whatever, however you handle your top priority items, do that. Track it, do all the things. But stop shutting things down. So this is the abbreviated version. I am actually going to get more into these details later today, so if you want to join me 301 later on, great. But for now, I'll leave you the words of Winston Churchill. Perfection is the enemy of progress. And for us in security, we do way too much of that. So quickly, invite you all to continue the conversation. My details are here. But thank you so much to all of you. Thank you to ATO for having me. It's been a pleasure, and we'll see you guys later on.